Okay, there are lots of temperature scales out there. For example, the one that we're most used to is degrees Celsius. You've probably heard of Fahrenheit, which Americans use. And the one that we need to know is Kelvin. Okay, we actually don't need to know Fahrenheit, so I'm rubbing that out. You can define a temperature scale using any 2 points that join up to make the line. So for example, degrees Celsius scale is made from the temperature at which ice melts and the temperature at which water boils. But the thing is that even at 0 degrees Celsius, the particles are still moving. They still have kinetic energy and they still have potential energy as well. So we're going to use a different scale now. We're going to use the absolute scale of temperature in kelvins, where at 0 Kelvin, the particles have minimum internal energy. And this one means that the particles are barely moving. They have minimum kinetic energy and they're right as close as possible to each other, so they have minimum potential energy as well. The second point that we need to define it is called the triple point of water, which is 273.16 Kelvin. And this is temperature, and there's a certain pressure as well at which you can find solid, liquid and gas, ice, water and water vapor coexisting at the same temperature. You don't know too much about that one, but the main thing you should know about is at absolute 0, the internal energy is minimum. Okay, to convert from degrees Celsius to Kelvin, you simply add 273. So 37 plus 273 gives us 310 Kelvin, minus 80 plus 273 gives us 193 Kelvin, and absolute 0, when internal energy is minimum in degrees Celsius, is extremely cold, minus 273 degrees Celsius, and it's extremely hard to get to that temperature, to cool something down to that temperature.